Good morning, students. This is our fifth lecture on sampling theory. In last lecture, we solved some examples on independent samples in small sample case. Now here, second type is dependent samples. In last lecture, we used t-test. Now here, we are going to use paired t-test. So this test is, if the sample sizes are equal, that is n1 equal to n2, then assume null hypothesis to be mu equal to 0, alternate hypothesis as mu is not equal to 0, and our statistic is t equal to x bar minus mu divided by s divided by root n minus 1, and degrees of freedom nu is n minus 1, where this s is a standard deviation of sample. Now see the example. A certain injection administered to each of the 12 patients, resulting in the following increase of blood pressures: 5 2 8 minus 1 3 0 6 minus 2 1 5 0 4. So can it be concluded that the injections will be in general accompanied by an increase in blood pressure? So we are going to use here paired t-test. One sample with data is given here. So paired t-test formula is x bar minus mu divided by s divided by under root of n minus 1. So here value of n is given. N is 12. Now values of x are given. We have to find out x bar. Then we have to find out this mu. And we have to find out s. But observe here, in our null hypothesis, we are considering mu equal to 0. So we will find out x bar and s. So first we will calculate x bar and s. So here in this table, first row contains the given values of x. Now we will consider di equal to xi minus 2. You can directly consider this, no problem. You can directly consider. You can find out x bar from this data directly. We will consider di equal to xi minus 2 and di square. So when x is 5, di means xi minus 2, that is 5 minus 2, that is 3, and 3 square is 9. So 2 minus 2, 0, 0 square 0, 8 minus 2, 6, 6 square 36, and so on. 4 minus 2, 2, and square is 4. So these are the values of di. So summation of di is 7 and summation of di square is 109. So here we can use x bar equal to a plus summation of di by n, where this a is this number. So 2 plus summation of di is 7 divided by number of element in sample 12. So 2 plus 7 by 12, which is 2.58. Now second part, in calculating s we require this summation. So summation of xi minus x bar square equal to summation of di square minus summation of di whole square by n. But summation of di square is 109. So 109 minus 49, that is 7 square divided by 12, which is 104.92. Therefore s is under root of summation of xi minus x bar square by n, which is under root of value of this summation is 104.92 divided by 12, which is 2.95. So we have to test h0 is defined by mu equal to 0, h1 is defined by mu is not equal to 0. So using the statistic t equal to x bar minus mu divided by s by root n minus 1. So x bar is here 2.58. So 2.58 minus mu is 0 divided by s is 2.95 divided by under root of n means 12, 12 minus 1, which is 2.89. So level of significance is not mentioned here. So at 5% level of significance with nu equal to n minus 1, which is 11 degrees of freedom, tabulated value is 2.201. You can see this value in table. So here observe the things. T calculated 2.89, T tabular 2.201. So here T calculated is greater than T tabular value, so we reject H0. And rejecting H0 means it can be concluded that the injections will be in general accompanied by an increase in blood pressure. Now our second example is The following data relate to the marks obtained by 10 students in two tests, one held at the beginning of the year and other at the end of the year after intense coaching. So data is given, test 1 marks, test 2 marks. Do the data indicate that the students have benefited by the coaching? So test 1 marks are given, test 2 marks are given. We have to compare whether. So test 2 marks are after giving coaching. We have to test whether the coaching is benefited or not. So we will take the difference between these 2 marks and we will study it. If that is our with pair t test, we will check it. Okay. So first we calculate x bar and s, where x is difference between marks in test 2 and marks in test 1. So first row marks in test 1, second row marks in test 2, and third row is x, which is difference between marks in test 2 and test 1. So 68 minus 70 minus 2, 70 minus 68 2, 52 minus 54 minus 4, and so on, 55 minus 58 minus 3. So this is our x. So consider di equal to xi minus 2, that is deviation. So minus 2 minus 2 minus 4, 2 minus 2 0. So minus 4 minus 2 minus 6, and so on, minus 3 minus 2 minus 5, and summation of di is minus 19. Di square minus 4 square 16, 0 square 0, minus 6 square 36, and so on, minus 5 square 25. So summation of di square is 679. We know these two formulas. X bar equal to a plus summation of di by n. So here a is this 2. So 2 plus summation of di is minus 19. So minus 19 by 10, which is 0.1. Summation of xi minus x bar square equal to summation of di square minus summation of di whole square by n. So this is 679 minus summation of di square. So minus 19 square, 361 divided by 10, which is 642.9. Therefore s equal to under root of summation of xi minus x bar square by n, which is under root of divide this by 10, 64.29, which is 8.01. So I have to test h0 defined by mu equal to 0 and h1 mu not equal to 0. Therefore t equal to x bar minus mu divided by s divided by under root of n minus 1. So 0.1 x bar mu 0 divided by s means 8.01 divided by 10 minus 1 root 9, which is 0.037. So t calculated is 0.037. Now level of significance is not mentioned. So at 5% level of significance with nu equal to 10 minus 1, which is 9 degrees of freedom, t tabulated value is 2.262. So calculated value 0.03, tabulated value 2.2. So here t calculated is less than t tabulated, therefore we accept h0, and accepting h0 means the data indicate that the students have benefited by coaching.